Hello, hello. Good evening, guys. Thank you for joining me today on the MongoDB YouTube channel. And I'm going to be talking about, obviously, you can already know what I'm talking about. I'm going to be talking about Gen AI. I'm going to be talking about how we can build Gen AI application using the POLM stack, POLM, the POLM stack. I'm going to be going over some high level concepts about Gen AI. What are we building? Why MongoDB for AI? And then we're going to get into the code. So without no further ado, we can get started and get on with the show. This is going to be very jam packed and it's going to be, there's going to be loads of information. So get ready. So I'm going to start with sharing my screen. Okay, let's go with this one. Excellent. And we can see my screen. Excellent. So the first thing I always start with is every code I'm going to show you guys here today, you're going to see it in this GitHub repository uploaded within a day or so. This repository contains a wealth of information about generative AI and building AI applications using different stack components. So we touch on how you can build RAG pipelines. We talk about how you can build agents, agentic systems, and use different model providers, programming language, and other areas of the AI stack to build your AI application. So all the code you're going to see today is going to be going into this app folder, which contains full app folders that you can just clone and you can just get started with your application straight off the bat. So it's a bit different to the notebook that we're used to. This is the one we're going to be showing you today is a full application. But let's go through some high level concepts over here about what we're building, Gen AI, AI stack, and MongoDB. So we'll start from understanding what the AI stack is. And this is very important because we're going to be building an application with different areas of different components of the AI stack. So whenever I speak to developers, I talk about the AI stack having the several layers where we have the programming language, which in this case, we're going to be using Python. But you can build Gen AI products with pretty much the dominant languages today are Python, JavaScript, TypeScript. We see Go coming up there as well. But also, the model provider is an important consideration for the AI stack. A lot of people are debating open source versus closed source, fine tuning, what model should I be using, embedding model, and there's so many there's so many consideration when you're thinking about your model provider. Then we have LLM orchestrators and frameworks. This is where the LangChain, the Llama Index, the Haystacks, the Crew AI, the AutoGen. This is where they live. They help you build this LLM applications. But what we're seeing here now are operational and vector database. This is what we're talking about today. This is where MongoDB fits in, giving you both your operational database and your vector database in one, so you can store your normal transactional data alongside your vector data. We're going to see a lot of that happening, and then monitoring and observability and deployment. But if you want to understand more about the AI stack, we have an extended piece that touches into this. So you can just search this link or type in AI stack on Google search, and one of the first few links to come up should be one from MongoDB. But let's take a step back, right? What are we using this AI stack to build? We started off with LLM powered chatbots, and this was it's almost 2 years ago that ChatGPT came out, right? It came out around November 2022, and I don't know if it's the same for you, but to me, it feels like it's been ages since we've had ChatGPT, but it's only been 2 years. But so much has happened in between then and now. So today we have LLM power. 2022, we saw LLM power chatbots emerging, and this is chatbots that have this behind the chatbots where this large language models that essentially allow the chatbot to provide responses in natural sounding language, and with such human mimicry that it really transformed how people interacted with language models. But then we realized this language models needed relevant data they seemed to hallucinate, and we needed to tap into the resources and actually use them with our proprietary data within either within the organization or for commercial use cases. So we have RAG, retrieval augmented generation, which is a mechanism that allows for the retrieval of relevant data that is supplemented and passed into an LLM. Now, how we do retrieval, we're going to be covering that. We're going to be covering the techniques on how we can retrieve relevant data. But with RAG chatbots, what you have is this personalized experience with tools like ChatGPT. But then the LLMs, the model providers trained these LLMs to even have more parameters, and more emergent abilities started to emerge. So we saw emergent abilities such as tool use, reasoning capabilities, and just advanced planning as well. So what we observed is this emergence of AI agents due to the growing abilities of LLMs. But you connect this LLMs with a bunch of systems components, and you move into the world of agentic systems or compound AI systems. Essentially, you have an LLM that can make a decision to leverage tools that you've provided the information about. So that is agentic systems in a nutshell. But what we're going to be covering today is actually I'm going to try and hit all of these form factors, right? But we're going to build a chatbot that has RAG within it, but we're going to see some sort of indication of an agentic behavior with this chatbot. So this is going to be this code, this repository that you're going to be getting later is going to contain a lot of information. So how do you retrieve relevant data for RAG? And you could be building RAG pipelines or agentic system. It all comes down to providing the best data, the relevant data to the LLM at any execution step. So retrieving relevant data, today we have various ways of retrieving relevant data. We've seen full text search, we're very familiar with it, but now we're seeing a lot of vector search use cases, a lot of retrieving data by using semantics, which is retrieving data by looking at retrieving data by meaning. So now we're moving into the realm of embedding models. But then you can combine full text search and vector search together, and that gives you hybrid search. But MongoDB, we provide a platform that encapsulates all of this search capabilities and more. So we have MongoDB Atlas Search, which gives you full text search and even more functionalities. And then we have Atlas Vector Search, which allows you to conduct vector search operation and allows you to find using a query vector and some documents containing embeddings in your database, find the most relevant relevant documents to your query vector. And I'll put a pause there because I always leave this till later, but you guys can ask questions on the comments in regards to what we're talking about and in regards to AI in general. But bringing it all together, we have the MongoDB query language, which allows you as a developer to intuitively query data within a MongoDB database. And the MongoDB query language is very familiar. It looks like JSON, it feels like JSON, and we see it really reduces the amount of cognitive work you have to do to start to construct query when you have things are just when you have your query language in a familiar structure. So I'm going to touch on some of the searches that we've been talking about. Then we'll move into what we're building today. Then we can at least start actually getting to the code. So MongoDB Atlas Search, typically text search works relatively, text search is relatively simple. You have a search query coming from your application layer, send it over to your data through the backend, and then you can search for documents using the MongoDB query language based on the search query. And then you you retrieve some documents that are based on the text search that you've conducted, and you can then use this information, or you can just display the result to the user. But then you have Atlas Vector Search, where you have a query entered into the application, then the query is passed as input to an embedding model, and then embeddings are generated, and embeddings are numerical representation of a data object, but it allows us to start plotting a bunch of vectors or a bunch of vector embeddings in a high dimensional space, and using mathematical functions to calculate the distance between them, and the distance and the closer two vector embeddings are in a higher dimensional space, the similar they are in meaning, essentially. So we have this numerical representation of a data object, and then we are able to then conduct retrieval using the query vector against some of the documents we have in our database, in our MongoDB database, that have embeddings alongside. And with this functionality, you can start building techniques. You can start implementing RAG, or building semantic search, or actually building recommendation system and more. But you can then get the best of both worlds with hybrid search, where you have a query, and the query uses both vector search and full text search, where you're retrieving by similarity and you're retrieving by keyword. You combine the results to get hybrid results, re-rank the result based on some method, and then you're able to get a combined fused results from two different form of searching for data. And all of this is just getting the relevant data from your database. So MongoDB focuses on essentially performance, scalability, and providing you with the tools to retrieve the data that is required for the next step in your AI application. So now we're talking about AI agents, and I always shy away from giving definitions of AI agents, because the definition of an AI agent is within a spectrum. What does it mean for something to be agentic? It's up for debate, but I define an AI agent as a computational entity that has some form of awareness of its environment, and it can perceive its environment through input. So this can be text, images, sound, and it has cognitive ability. So this is where the LLM comes in. So an AI agent needs the ability to reason and plan. And also, to just run it all up, the AI agent is equipped with some form of memory, maybe long-term or short-term. So these are characteristics of an AI agent, and you could work backwards and form a definition. But again, up for debate. But let's talk about the key characteristics, right? We have perception, which it can be text, audio, images, or any other data form coming into this computational entity that is then able to plan a next step of action. So when you give an AI agent an objective, it's able to look at the data you provided it, or gather data from other places using a bunch of tools that it has awareness of, and then it's able to then plan and execute a sequence of steps. So all of this is also backed up in memory, short-term, long-term, and the different forms of memory that we're going to be talking about in a few slides. So there's a lot going on in the slides, but it's not complicated. It's just a visualization of what we're going to be building today, or what I'm going to be showing you today. So we're going to have a data source. We're going to ingest the data source into a development environment, and we're going to prepare our data. We're going to do some splitting. And in this scenario, you start to explore things like chunking strategy and data validation and data completeness as well. Then we're going to generate an embedding of each of this chunk. And alongside with the embedding and the metadata, we're able to store those two data types in MongoDB. And what we're going to be doing in this particular session is providing the ability to retrieve data as a tool to a AI agent. And then the AI agent could go through an iterative process of calling tools and reflecting on its previous steps to actually achieve an objective that we've provided it as a prompt. So this is a very high level overview of what we're going to be working on today. But if we zoom in and look at what role does MongoDB has to play in the agentic future. And one thing I see a lot, and we see a lot of customers doing, is using MongoDB as that memory provider for the agentic system, right? So if you think about a human needs memory. We need memory to function, and there are different forms of memory in the human brain. But you can see that within agentic system, they also need some form of memory, various form of memory to ensure performance and reliability. And with MongoDB, you get this memory provider solution that can actually scale as your application scales as well. So knowledge base is pretty obvious, as in you can think of this as RAG, a RAG type of functionality. So the knowledge base is pretty much prior knowledge that the AI agent has within of a certain problem domain, and the AI, and you could implement sort of like an update to the knowledge base, an update implementation step. Then a profiler is it's the type of memory that it could be short term or long term. It depends on how you implement it. But this form of memory, it captures the entity that your agentic, an AI agent is actually interacting with. It could be humans and it could be other systems as well. And by capturing a profile of the systems or entities it interacts with, the agent can tune its response based on a user profile or system profile. So again, and we go into toolbox. If you think of agents, the way they work is you need to actually give the LLM an awareness of all the tools it has within a system, and this is typically passed into the context window of an LLM during inference. And what you have to pass in is a JSON definition that contains all the attributes of a function that represents a tool. So you can imagine very quickly, if you're building this agentic system at scale, when you have a system infrastructure with 10, 20, 30, in some cases, hundreds of tools or hundreds of functions, and you will start to exceed the context window of this LLM. So one thing that you can use MongoDB for is use MongoDB as a toolbox. So we define tools using JSON, and in MongoDB we're able to store tools using JSON. Then in inference time, you could just do a vector search in some of the tools in your MongoDB collection, and you could just retrieve the relevant tool, maybe 2 out of the hundreds of tools you have in your toolbox, and you could just retrieve in query time the tools you need for that particular query. But the standard ways of working with memory are data store, and we see that with MongoDB as well. And we also have working memory, which is a form of active memory where you're updating memory in real time, and also you're retrieving memory from your knowledge base as well. So MongoDB does a lot within the AI stack, and we integrate with a number of key players in the AI stack. So if you're using MongoDB with any of these providers you see on the screen, any of these integration partners, you can rest assured MongoDB is there. There's an implementation to utilize MongoDB as your vector database and operational database in one, and also your memory provider for your agentic systems. But just to look at just to sort of address a common pattern that we're seeing, there's a lot of databases that were built, some traditional databases, relational databases that were built in a time pre the AI era, right? So these databases have their place, but in AI workloads, we're looking at more modern databases that can handle robust data structures, even and have flexible schemas. Because as we can see with AI workloads or with Gen AI product, the data that you might need to capture tomorrow, you might not be aware of today. So with MongoDB, we have this evolving schema architecture that you get out of the box with MongoDB. But with relational database, we see people using the relational operational database and placing on top of them specialized databases. Now you have 2 databases you have to manage, 2 different sets of developers, 2 different sets of teams managing 2 databases. Well, or you could have a super developer that manages both, but they're going to get burnt out very quickly when they're moving from one system to another. But with MongoDB, you have a single solution where you can have your vector data sitting alongside your metadata, your operational data, and you can then query them using the same query language. So it's very simple to visualize, and it's very simple to think about. But today we're talking about the POLM stack, and this is POLM, And this is Python. That's what the P stands for. That's the programming language we're going to be using primarily to build out the AI, the AI aspect of this Gen AI product. We're going to be using TypeScript and JavaScript as well, but focusing on the AI aspect and not the web aspect. We're just going to be using Python. And why we're using Python? Well, Python is a very familiar programming language to most developers. It has a rich ecosystem of libraries and integration. It's easy to use. The syntax is really easy to pick up, and it's not complicated. And you have a lot of we have a lot of libraries and tools that allows us for different data manipulation. So in a RAG pipeline or in a data ingestion pipeline, you're going to have to sort of wrangle with data and clean data and modify data. And Python has a lot of libraries that are specialized for this particular use cases of data modification. And then we have a strong community support with the language and with packages within the language. The O, you probably guessed it, is for OpenAI. Why OpenAI? Well, it has a very easy to use API access. You can access it through REST API or just use the OpenAI client. And very easy and very simple model development. The models keep improving on OpenAI. They have embedding models and text generation models, and the documentation is pretty easy to understand and go through. And again, there is a community presence of folks using OpenAI as well. So you can, if you run into an issue, you can probably go to the forum or search online. Then the L is the most interesting bit, or the M is the most interesting bit, but the L is also interesting. So we have LangChain, and in this case, we're going to be using both LangChain and LangGraph because we do have that agentic element within this tool we're going to be showcasing today. So LangChain is good for rapid prototyping, but with the solution ecosystem they're building out with LangChain, LangGraph, LangSmith, you start to build this robust ecosystem that can support your application. So again, the application, the tool, the code I'm going to be showing you has some LangSmith integration in case you want to use LangSmith. And LangChain is very well integrated with MongoDB as well and has a decent community support. Then we get to MongoDB. It's going to be your all-in-one solution for data storage, and what you're having is your vector data. What you have is your vector data, and your operational data. I'm gonna have to take a second. I seem to always choke on this live streams. And I'm back. I think that's the second time that's happened. But one thing we can do is use that as a break to think about your questions that you want to ask me. So I think I'm okay. I'm going to take another drink just in case. Yes, it is engaging. I'm glad you engage. Ask questions. Make anything you're thinking about with AI. I have so many questions every day. So let me go back in. I think I can actually start going, finish off the slides, and we can start talking about the code here. So let me just quickly finish this off. And this is where we are. I think this was the last slide anyway. So we have the POLM stack, right? POLM, and we're going to use this to build our Gen AI powered app. So we can get to the fun stuff then. Not saying everything has not been fun so far. So if you want, very quickly, do go into this repository, and when you do leave a star. It shows us we're doing a good job. Fork it, clone it. All the code we're going to be showcasing is going to be going into this app folder within the next few days. And also, very quickly, there's another repository you might be interested in, which is this HR Agentic chatbot, which is also linked on the use cases here as well within the main Gen AI showcase repository. And everything I'm showing, there is going to be notebook versions you can find as well in that repository. So you can find this particular notebook. This is a notebook version if you don't want a full app. There's a notebook version. You could also, we have the quantize, the ability to ingest quantized vectors got released recently. We have a notebook covering that as well. For those of you that are looking at enterprise use cases or commercial use cases exceeding 1 million plus embeddings. This will save you a lot of memory space, a lot of storage, and also operational costs for your Gen AI application. On that note, we can stop presenting. I was just about to click the leave the studio screen. So let's present the code, and let's go to share my screen again. And I think we're good. Okay, so what are we building today? If you've watched this when I'm on, you would know that I'm trying to become an asset manager. I'm trying to transition into the finance industry. That's a lie. I'm a developer for life, but I am trying to solve a problem within the finance industry, which is centered around compliance. So the finance industry and financial institutions get fined every year, yearly, several hundreds of millions of dollars or pounds. And the reason why they're getting fined is for the violation of certain policies. Right. So what we're trying to build here is some form of system that when it's given a transaction, it can determine if a policy has been breached, what policy has been breached, and could probably send a quick alert to some folks that are some investigative team within the financial institution. But today, I'm just going to zoom in. There's going to be maybe some zooming in and zooming out. Here we have a backend. This is where the POLM stack is going to reside, and we have the front end, which is a very simple React application. It's just one page. I can go through it very quickly. So we just have a very simple React application here, and it's just a one pager. And what we have is a simple text box. Let me start to highlight the key aspect of it. So we have a simple text box where the user can input a query, and then they hit send. The query goes into the backend, exposed via the functionality of the backend is exposed through REST API. And then when we get to the backend, we're handling the query, and we're taking the query and we're passing it over to an LLM that goes within this agentic process, and it can determine what tool to use to actually solve the query objective. So that's what we're working on today, and all this code is going to be in the Gen AI showcase repository. So that's the front end, and let me see if this tool is running. It's running, which is great. And obviously live demos are always really tough to do. So I've tried this several times, but if something goes wrong, I will just talk through what is meant to happen. So I am going to switch my screen again. I apologize for that, but I want to show you what we're building, what we're going to build, and then we can work backwards as to how we've built it, and then how you can modify this folder and the contents within it. So let's present another screen. All right, so we are here. Oh, spoiler. Let's go. So let me refresh the page and we could go. I should probably delete the history, but I'm just going to say hi there. Let's go. So hi there, and hopefully it responds back to me. So it says, just going to zoom in a little bit more. Okay, hello, how can I assist you today? Do you have any financial transaction or policy compliance questions that you need help with? So this LLM, the LLM behind this chatbot, so this is, remember that form factor evolution I was talking about? If I just quickly go back to the slide. As you can see, there's a lot of information. So that form factor evolution that I was talking about, very simple LLM power chatbot that we have here that I just closed. Very simple LLM chatbot. And this LLM chatbot has essentially been conditioned by prompting to answer questions around financial transaction and policy compliance, right? So that's why it keeps saying, hey, if you need any assistance with financial transaction or policy compliance, we should let it know. But this LLM chatbot is not just an LLM, it's powered by RAG as well, retrieval augmented generation, which means that every query we're passing it is deciding if it should use its knowledge base to answer the query, or just respond using the parametric knowledge of the LLM, which it's doing in this case. So right now it's not using its memory, but it's not using any data or knowledge source. Let's ask it, what can you do? What can you do? We'll see what it responds with. Okay, it's extensive. So I specialize in analyzing financial transaction, which is great. Here are some key tasks I can perform. So it can analyze incoming transactions. So remember when I said banks get fined for transactions and handling transactions that violate some policies. Now, this system, we can place the transaction information into it, and it can then analyze it and let us know if it's violating some policies, or what policies this transaction are essentially related to. So we got this policy compliance check-in functionality as well. We've got the ability to update the transaction status of the transaction we've sent in, answer questions about policies and other functionalities. And each of these functionalities is actually a tool. Is actually a tool that we've provided the agent to have access to within our system. So the update transaction statuses is actually going into the MongoDB collection and updating a particular transaction information. And when we send in a transaction through this chat interface, we're actually going to add that transaction into the MongoDB database as well, into a specified collection. I'm going to take you through all the steps of how we ingest the data and prepare this application for use, but it's a very simple chat interface, which means you can get the code for this application and just modify it to for whatever use case you have. So we'll show you all the information around what we're building. So one last thing is to show you the transaction functionality we have here. So I'm going to tell it to get me the policies this transaction is related to. So I've just got a transaction that I copied and pasted. This is it over here. And I can't spell. I've made some spelling errors in several different places, but it doesn't matter. What we're going to see is it's going to conduct vector search using this transaction information against some of the information we have about policies within our database. And with that vector search retrieval results, we're going to see the policies that it corresponds to. So again, I'm working backwards, showing you what we're building. Then we could go back to the code and talk about how we built it and how you can modify it. But very quickly, it's provided us some policies that are related to this transaction. And you're probably asking, Richmond, where are these policies coming from? Well, what you're going to get with this code base is the link to a MongoDB Hugging Face organization that contains a bunch of data you can use for your use cases or proof of concepts. So very quickly, within this database, this is a financial use case, finance compliance use case database. We have policies, which contains 100 documents of different policies that are from different parts of the world. These are essentially generated by an LLM. These are not official policies. This is synthetic data, but it's just good for proof of concept. So we have a bunch of policies, the policy name, the description of the policy. We also have the regulations within the policy. So all transactions exceeding $10,000 must be reported to the financial, to the National Financial Authority. So we must actually be able to detect if there's any violation of this policy by an incoming transaction. And what you can see here is there's an embedding data type with this document as well. So we have both our, just going to zoom in there a bit. So we have both we have our metadata where we can perform different typical searches that we're familiar with, which could be text search, but we can also perform vector search within the same document as well, within the same query language, within the same database. So it makes things very easy to think about and to actually access. So we have policies, and one thing you're going to notice as well is we have transactions. So what happens whenever we pass a transaction into the tool is something happening behind the scene is there's a tool that can actually add a transaction into the MongoDB collection. So the agent behind this chatbot is actually aware of methods to actually insert an incoming transaction data into an existing collection. So for it to generate this answer, it's gone through at least 3 different tools. So it's been able to analyze the report, the transaction, ingest and insert the transaction into a collection, then actually conduct vector search against the content of the transaction and some embeddings within the vector, within the database, and which is the vector embeddings of the policies. And so this is us working backwards. This is where we're at. This is it. So just to see the report, it's highlighted the transaction over here, and then it's highlighted the policies that that are associated with it, and it's actually included the violation of the policies as well. And the transaction is over 50,000 purposefully, so we can actually violate the 10,000 euro policy or regulation for this certain policy. So policy 1 has been violated, and we have the reason, and there is this reason, and all of it are pretty much the same, just so you just for testing purposes. But this can be different policies and different number type as well, value types. So these are the policies. We are able to retrieve 5 policies. And one thing is I want to point out is this is using OpenAI as the LLM, OpenAI as the embedding model, but it's quite a plug and play approach when you're using tools like LangChain or tools like Llama Index. You can actually switch model providers quite easily. So this is where we're at. This is what we got to. There's also a bonus. I'll show you a model released by Google that is specialized to handle the enforcement of policies. So we have a notebook for that as well, which is over here. The notebook is over here. So this notebook shows Shield Gemma and how you can use it to enforce certain policies. But this is the application that the code base allows us to build. Now we're going to go back to the code. I'm going to stop sharing the screen, so start sharing again. Please ask any questions you have. There are no boring questions. So let's share the screen again, and we're going to look at the code. So behind the scenes, what happened when we made, I think, is that too much zoom? Behind the scenes, there's a lot that happened. Very quickly, we actually made a response. We made a query. When we inserted a query by text, we made several queries because we were like, hi there several times. But this is a query that contains the actual transaction. As we can see, it actually inserted the transactions. Then there is one that actually conducted the vector search, and we can see the result of the vector search. The documents is retrieved. There's a lot of, again, this is the documents that we've seen in the MongoDB database. And this is just the terminal output of the process. But here we can also see the insertion of the transaction as well. So this is another tool that inserts the transaction. And I'm just going to zoom out, and we're going to pull this down. And we're going to go through. I've explained the front end, very simple stuff happening here. This is all the code for the chat interface. Then we can quickly talk about the back end, where the POLM stack really shines. The way you want to start with this is really setting up the front end first. You can go into the front end, install the packages, and just run npm run dev, and then you have your front end running on port 3000. But for the back end, we would just talk about this process. Once you go through, navigate to the backend directory, set up your environment. I use Conda for my environment manager, and then pip install all the packages in the requirements.txt file, set your environment variable. So we have all the Flask, the production, not the production, the environment type of the application, your MongoDB URI connection string, and then you have your other information, your OpenAI key, and your database name as well. Then you can start the Flask server. So we go through an ingestion, zoom in just a little bit there again. So when you start this application, once you've set up your front end, you've set up your back end, and you start the application, we need to actually supplement. We need to actually load some data into our MongoDB database. This is the knowledge base of our agentic system, of our AI agent. So you just run this script, ingestion.py. And what does this script do? We can have a look at it very quickly. So with ingestion.py, we're loading our environment variable. We're obtaining our Mongo URI string. But very quickly, we're using a bunch of tools there. We're using Pydantic to make sure that the data that we have within the system sort of conforms to certain expected models and data attributes. So this is what we're doing. So we have models for essentially what is a policy. This ingestion, what this does is it ingests a bunch of policies from a data source over our Hugging Face. So this is that fake synthetic data I was talking about. We're going to set up our Mongo client. We have a function that sets up our Mongo client using PyMongo. Then we convert a row within our data set into a policy type. So every row within the data set, this function actually converts it into the policy model that we defined earlier. So after that, we're able to then generate an embedding on a certain data type. So on a certain data attribute, what this function is going to do here is for every data point within our data set is going to get an input of a text attribute and generate the embedding. And we saw this in the MongoDB database. And now we're going to prepare the policy text. What the prepare policy text is, it selects a few variables that allows us to pass as input to the embedding model to generate our embedding. This function just adds an embedding to a policy, and this actually uses the prepare policy text and then passes the text into the get embedding function to generate that embedding. Then we can add, this is just a function to add an embedding with progress. We can see the progress of the embedding being inserted. We can see a progress bar on the terminal. Then very quickly, this is the main part of it. We're loading our data set over here in this MongoDB organization on Hugging Face. You're gonna need a Hugging Face token within this application environment in your .env file as well. Next, we're going to use all the functions we've defined earlier. So we're going to apply the rotor policy function on the country policies data frame. And then we can generate, this transforms every data point into a policy model. And then this generates an embedding for every data point. Then we obtain an object of our MongoDB client, and then we can insert the policies into MongoDB in basically with one line, with basically one line. You can write most of this in one line. But also we create an empty transaction collection. So that's what the ingestion process is doing. So we're preparing our data here. So we're loading information into MongoDB collection, and then we're creating another collection called transactions. Then the next step after you've done this is to essentially build your vector indices. So we have another script for that, which is create index. Very simple, almost similar step. We're going to get our MongoDB client, but then to create our vector index, we're going to define, I'm going to start backwards. We're going to define a definition, a vector index definition, and then pass it into a function that's going to programmatically create this vector index for us. And you need to execute the script for us to be able to conduct vector search. Now, what does your vector index definition look like? Well, it looks like this. We're creating two, just so you know. We're creating one for the transaction collection and one for the policies collection. So with your vector index, you're going to specify the fields you want to you want to base your index on. So, and the type of index we're creating is a vector. We're going to be specifying the path where the vector embeddings reside within the document. This is embeddings. And then we're going to specify the number of dimensions of a vector embedding coming out from the embedding model. This is going to be, in this case, I believe it was 256. This is going to be 256. Then we're going to specify the distance function we're using to measure the distance between two vector embeddings, and we're going to be using cosine. So we call this function twice for each of the collections we have, which is the transaction collection and the policy collection. Exciting stuff. So that is our data ingestion done. We were able to ingest the data, create indexes. Now we can actually open the browser. You've probably done this in the previous step. And then you can start to ask questions about specific policies and submit transaction details submit transactions for compliance checks. And you can also request explanations of compliance decisions. And we've done this already. Remember, we worked backwards. We started from what we built, and then now we're looking at how we've built it. And the key components here are the front end, the back end, the database, and the large language models we're using. There is an aspect of this code where we're using Shield Gemma, which is a variant, which is a model created by Google, which is a variant of the Gemma 2B, which is a variant of the Gemma family, and it's specifically been fine-tuned for checking the compliance enforcement based on an input. I've said that sentence very wrongly, but Shield Gemma, you give it an input and is able to check if the input is sufficiently meets a policy that you specified. So there's a code that shows how you can use Shield Gemma, but there is also a notebook in the repository, the Gen AI Showcase repository, on how you can use the different versions of Gemma models. So this is the POLM stack. So let's stick to OpenAI. Again, there's a bunch of information if you want to carry on working on this tool. But one thing I want to start to focus on before we start to round up. So just to recap what we've done so far. Some of you might be joining us a bit late. We spoke about the AI stack. We spoke about the POLM stack, which is Python, OpenAI, Llama Index, LangChain or LangGraph, and then MongoDB, right? That's the POLM stack. And you can use the POLM stack with Llama Index, right? So again, or you can use LangChain with Llama Index. The L is flexible. So we have the POLM stack. We spoke about it. We spoke about the different searches that we can implement with MongoDB Atlas. We also spoke about the reasons why we shouldn't just be having two different databases for different data types when you could just have an all-in-one solution, which is MongoDB for your AI application. So that, and then we saw a tool that essentially, which is a chat interface that can take in a transaction and then actually give us some information as to the enforcement of a certain policy on this transaction. Then we've gone through the code base of how we ingested the data and how we created our vector indices, and now we're talking about other aspects of this tool, of this application. We're going to look at the agentic process of this application, right? This is an agentic system. We looked at the form factor of evolution. So far we looked at the LLM chatbot. Hi there, it said hi. That's just a chatbot, right? You can build a very simple if this then this chatbot essentially that just replies with a canned response. But we also asked it more questions, and we could see that this was a chatbot that probably had an LLM behind it that was also powered by RAG, because it was able to retrieve some information to supplement with the prompt, then pass that information to the LLM. Then we saw it enforcing, conducting the transaction policies and using a bunch of tools to actually enforce a transaction. So let's look at the agentic process. So I'm using LangGraph for this agentic process, and a good place to start. Normally, we use a notebook, so it's like you can just see things happening. But a good place I would like to start with is the tools. What tools do we have, and have we provided our agent with? So we have the policy checking tool. This is the one that uses Shield Gemma. But again, we saw the agent actually was able to use the OpenAI, its OpenAI capability to actually check for policy enforcement. But with LangGraph, you can actually steer this system to only use Shield Gemma for certain execution flows, or yeah, for certain execution flows. So we're using Shield Gemma. This one just checks transaction policy compliance using Shield Gemma. And one thing to take note is this decorator, tool decorator. This is coming from LangChain, and this essentially just allows this Python function to be, I guess, it allows it to be, it makes it more aware. It adds some additional attributes to this Python function that allows for the AI agent to, allows for the JSON definition of the Python function to actually be built. And that JSON definition is then passed into the context window of an LLM doing inference. So then from the information that we have, such as this description of the function, the LLM can actually know when and the parameters to enter using this this function. So this is the first function we're checking, but we have several functions as well. We have the process transaction compliance. So now this function checks a transaction and uses a policy checking function to actually check if a transaction is actually compliant. Then we have a transaction tool. This one is able to actually process an incoming transaction, and we can see here there's a function to extract some text from the transaction that we generate an embedding from, and this allows us to conduct vector search with the transaction embedding against the embeddings we have in a policy. So this is the key thing that is happening here, right? We've provided this agent the tool that allows it to, this is a function, and we've wrapped it in a tool, and we've allowed it to conduct vector search using an incoming transaction. So the agent, this function actually extracts certain fields within a transaction and generates an embedding of the transaction that then can allow us to conduct vector search on a range of policies within our collection. So this is where the magic is happening really with that specific tool. And then we return a string of the search results, because the reason why we're returning a string is because the Python functions, they can only take in the strings if they're tool definitions. That's why. So then we have the last tool, which is an update transaction flag status. So again, this application can actually update existing documents within the transaction collection. You just pass it the transaction ID and the policy it violates and the reason, and we can start to update transactions within an existing collection as well. And this is a tool that allows the AI agent to do this. So tools are just Python functions that are just wrapped around when you're using LangChain. You just use a tool decorator to create a JSON definition that is passing to the LLM. So the next thing we're going to look at after we looked at the tool, we can look at the agent setup, right? So this is where we define the LLM we're using for our agent. So here you can see I'm using the chat OpenAI abstraction, the chat OpenAI class from LangChain, and specifying the model over here. But very easy, you can switch to the POLM stack, the PALM stack, the POLM stack, and use Anthropic as your text generation, as the brain of your agentic system. But very quickly, this is a system prompt. We're just steering the LLM in a certain behavior, and we can see what the system message is here later on. But right after, this is a bunch of code we're using to define the prompt, and then we're defining our agent over here. specifying the prompt, and also binding the tools that comes from the toolbox. So I guess this is a good time to talk about the tool setup, then we can come back to the workflow. And then we could round up there. So in the toolbox, so we saw a bunch of tools, and here we can see the toolbox, but let's see where the tools is actually being used. It's going to be in the workflow. Here we go. So for the tools that we've defined, we actually import them into this workflow definition Python file. This is all connecting to our database. We're getting a client of our database. And now we create this custom toolbox, and it's we create a Python list that contains all the functions that we just went through, which are the tools. And we also create an agent state. So with LangGraph, you have the concept of a state, which is a data structure that just captures and stores all of the interaction within an execution or interaction within your agentic system. And this, again, with MongoDB and LangChain's integration and LangGraph integration as well, this is actually stored within the MongoDB database. So every interaction that's gone back and forth is stored within the MongoDB database in a collection called state store. And now we're going to create, we're creating LangGraph. We're creating a graph that is going to include a chatbot node, which is going to take that system message, and it's going to take the toolbox that we defined earlier in this file. Then we're going to create a tool node, which also is going to take in our tools as well. So we have a chatbot where our LLM resides, and we have a node where our tools reside. So now we can actually start to define the node. We're going to start with a graph. I like to call it a workflow, but we can start with a graph, and then in this graph we're going to define the nodes. So we're going to add a node called chatbot. We're going to add a node called tools, and then we can set the way the node, the flow of the execution is executed. So right here we have the entry point is going to be the chatbot. So a query goes first into the chatbot. Then we have a conditional edge where the chatbot could take on the query, or it can use, or the tool node can be accessed as well. Then everything ends, and this conditional edge also leads to an end state as well. But there we go. And now we set up our Mongo client, and mostly we're setting up a check pointer, and this is used to store the interactions. It's used to store the state that is being populated as the execution goes along within LangGraph. So all of this boilerplate is already written, and it's all in this MongoDB check pointer file. And the only thing you need to do to use this is just place in your MongoDB URI in the .environment file. And again, for those of you who are joining, all the code is going to be in the GenAI Showcase repository within a day or so. We just got to do a bit of a cleanup to make sure it's ready for you. So that is essentially everything in a nutshell. So we have this agentic process that is able to, where we define our tools, we set up our agent, we define the graph over here and the workflow, but then we can also handle user queries as well. So when an input comes in, we handle this file is responsible for handling the user query, setting the thread ID. Ideally, you want this to be timestamped, and you also want to append maybe a user ID to this as well, so you can always locate a conversation that a user can have multiple times. So this is just an ID for the current state, essentially, and this is stored in MongoDB within the state store collection. So this is how the user queries are handled. And then this is the workflow definition right here, or the graph definition. And that's it. That is a very, not simple, but I guess a very clear explanation of a GenAI product, right? So we have the back end, the front end. The front end is just a chat interface. Then we have in the back end, we have an agentic process, and we're exposing all of these capabilities with a REST API just called API /message, and that's it. So again, the code is going to be available for you guys. Give it 24 hours, and we're going to be updating it in this, just to show you one more time where the code is going to be in case you don't find it. It's going to be in this repository, the Gen AI Showcase repository, and it's going to be under the app folder. And right now we have codes there. This is another application that is built using Java that uses vector search with MongoDB as well. So if you're a Java developer, there is something for you here as well. So on that note, we can call it a day, and you guys have a good day. Have a good evening. Thanks for joining me and staying till the end or watching till the end. Take care, guys.